Hello and Assalamualaikum to Sir Iqbal. Today we would like to present about our assignment business statistic. Before that, I will introduce about myself and my partners. My name is Khairunisa. My partner's name is Khalifia Robert, Nur Ayu binti Jamal, Imagina and Rosminah Mansasa. Okay, I will pass it to Khalifia Robert. Kaylee will present about mean.
So firstly, we go to the mean as the first topic in this assignment. Mean is the total of number that is used to divide the central tendency. It is average of a group data. It is calculated by summing up all the observation in the data set, then dividing it by the number of data. The resulting number known as the mean or the average. So the mean is the most commonly used measure of central tendency since it reflects the average score representing the whole data set. For mean, we got two types of data, which is the first one is individual data or ungrouped frequency, and the second one is group frequency. This is the example of individual data. Okay, this is the formula. Total of x is when you sum up all this number, and the n is the total of data, which means when we got add here, then we write this add in here. So when we sum this number up and we divide it by 5, we will get 12 as the mean of the data. Okay, and for group frequency, for mean, each class interval is represented by the midpoint of the interval x. The mean is calculated as x equal to total of fx over total of f. So the first table we only have two tables like this, but when we want to calculate the mean, we need to convert it to four tables like this, added the midpoint and the fx table. So the solution is like this. Total of fx we got from the table above that we calculate from the product of midpoint and frequency. So total of fx equal to 6 at 6, and the total of frequency is 81. So when you divided it, you will get at 4.46. So this means that, and on that average, the employees in Khalifia's company have 8.46 years of work experience each. So that's all for me. Thank you.
There are two types of median. It's for group data and ungrouped. The definition of median is median is a simple measure of central tendency. To find median, arrange the number in order and find the two middle value. For example, determine the median for the following data. In this number, it is not in ascending number, so firstly, arrange the number in ascending order. Find the median for the following data. For example, after you arrange the number in ascending, then find the two middle numbers. Since the number is even, we can determine the median by computing the average of the two middle values, 3 and 7. For example, equals to 3 plus 7 over 2 equals 5. Finding a median for a large number of observations. If we have 15 data, the median is the 8 terms as shown below. Location of median n plus 1 over 2 equals to 15 plus 1 over 2 equals to 8. For another example, the number of student mark tests recorded as follows. Arrange the data in ascending order. If you already arranged the data and find two middle value, the formula is 4 plus 4 over 2 equals 4. The second is median for group data. N is for sample size. Lm is lower limit of median class. Cm is for cumulative frequency before median class. Fm is frequency of the median class. And C is the median class size. And this is the solution of the group data.
Okay, I will present about mode. Okay, mode is the value that occurs most often if no number in the list is repeated. Then there is no mode for the list. The data set may be said to be modal, while a set with more than 2 modes may be described as multimodal. The numerical value of the modes are equal to the mean and median in the normal distribution. In other words, mode, mean and median are the same in the normal distribution. They may differ in highly skewed distribution. Okay. For category data, the mode is the category that has the highest frequency. For example, okay, look at this and look at the graph. The mode is bicycle. Okay, for the quantitative data that is represented by histogram, the mode is the class interval with the highest frequency. Okay, look at the data. The highest frequency is 15 for individual data. Individual data is collected data that can be associated with one element in a sample is called individual data. Individual data also collected by person or they took from another source. For the example, all the data generated from John Doe's answer are individual data. All of the data collected in the survey in aggregate into aggregate. For evaluation, only with access to individual data can we make meaningful calculation in descriptive and inductive statistics. For the frequency distribution for group data, a frequency table summarizes the data collected by forming interval of value and indicating the numbers of the data that falls into each interval. The frequency table with class interval is known as the frequency distribution of group data. The grouping of data is often desirable because it reduces the complexity of the data. For the example is, okay, look at this. Okay, the rule of thumb is the number of classes should not be less than 5 and should not be more than 15. To determine the number of classes, K for a set of data, this K set of data, and consisting of an observation. The formula can be used. For example, if the number data is 60, then the number of classes K is log. Saya tak tahu macam mana nak sebut, but okay, log 60 divide to log 2 equal 5.9 or 6 classes. Finally, the frequency falling into each class indicate in the frequency table. It should not It should be noted that the number of observation in the data is equal to the sum. Okay, total of F equal N. Okay, for the frequency distribution for ungroup data, thus a frequency distribution is a table consisting of the observed value with their corresponding frequency. Okay, this is the example. Okay, I will show you. Okay, this is the example of question for the frequency and group data. Okay, this is the question and this is how they find the frequency and group data. Okay, consider the following set of data. This is a number for set of data. Okay, the value 1 occurs 3 times, therefore the frequency for value 1 is 3. Okay, 1 occurs 3 times. Okay, 1, 2, 3. 0 occurs once and therefore its frequency is 1. Okay, this is the 0. Similarly, 2 occurs 8 times and its frequency is 10 to then 8. Sorry. Okay, 1, 2, 3, 4, 5, 6, 7, 8. The frequency of 3 is 5, and that's of 4 is 3. Okay, 3 is 5. 1, 2, 3, 4, 5. Okay, for the 4 is 3. 1, 2, 3. Thus, the frequency distribution of the data can be expressed as shown like this. Okay, this is the frequency distribution of the data that we find before. Okay, we should make a table and then list down X for the numbers, F for the how many occurs the numbers.
Assalamualaikum, I bid to Iqbal, our business statistic lecturer. Today I will explain about quartile. As we know, there are 5 different groups of number that can form quartiles. The first one is the minimum value, also known as 0th percentile, and then the next one is the number that has been splitted to the lowest 25% of the group from the highest 75% of the group. And then the third one is median, also known as the 50th percentile, is the millionth group of number. And then the last one is the maximum, or the 100th percentile, is the enormous number in the group. We can do the box and whisker plots to represent the groups of quartiles. Okay, this is the box and whisker plots to represent the quartiles group. Okay, next I will explain about the first quartile. First quartile is the number that has been splitted to the lowest 25% of the group from the highest 75% of the group. And to identify the position of the quartile, we use this formula. Q1 equal to n plus 1 over 4 to find the position of the first quartile. As we know, there are 2 types of data, which is group data and ungrouped data. And I will show you the formula we use for ungrouped data, which is Q1 equal to L1, which is lower boundary for the first quartile, plus C in bracket n over 4 plus f capital N over f small letter. L1 is considered as the lower boundary for the first quartile. C is the class interval of the class interval, and then n is the total of the frequency. F is the cumulative frequency before, and small letter of f is the frequency on the first quartile class. Okay, next is the third quartile. Third quartile is the number that split the lowest 75% of the group from the highest 25% of the group. We use this formula to identify the location of the third quartile. The formula is Q3 equal to 3 in bracket n plus 1 over 4. N is referred to the total of the frequency. Okay, same like first quartile. Third quartile also have their own formula for the group grouped data, which is Q3 equal to L3 plus C in bracket N over 4 plus F over F. L3 is stand for the lower boundary of the third quartile class. Class interval N is referred to the total of the frequency. Capital letter of F is referred to the cumulative frequency before, and then F is referred to the frequency. Next, I will show you how to how to find the quartile for the ungrouped data for the Q1, median, and first we gonna find the first quartile. We use n plus 1 over 4 to find the position of the Q1. So we know that n is the total of the data. So 12 plus 1 over 4 equal to 3.25 order observation. So as we know here that the Q1 is here, the position of Q1. And then next, for the third quartile, we use this formula 3 in bracket n plus 1 over 4. And then we got 9.75 fifth order observation. So this is the position of the third quartile. Okay. We must follow step by step here. The first step, arrange the data in ascending order if the data is this order. So arrange first. Okay. Next, for the group data. For the group data, the question is asked to find the first and third quartile. So the step 1, create the cumulative frequency. And this is the cumulative frequency table. And then step 2, identify the position of the first and third quartiles, then determine the position on cumulative frequency column. Okay, to identify the position of the first and third quartile, we use the formula before, which is n over 4 for the first quartile, and then 3 n over 4 for the third quartile. And for the first quartile, we got 25. So we refer back to the cumulative frequency table. Find the value that near to the 25. 52 nearest to the 25. We must choose the highest number in cumulative frequency. For the third quartile, we take the 80. And then for the step 3, determine the values of Q1 and Q3. As you know, here this is the class for the first quartile, and then this is the class for the third quartile. Okay, we use the formula for the group data for Q1 and Q3. And we calculate, we got 8.41 for the first quartile and Q3 11.64. Next, the last one, we do the graph. For the graph, the y-axis we use cumulative frequency, and then the x-axis we use upper boundary. To find the location for Q3 and Q1, we use that formula. we take the answer from here, and then we insert here into the graph, and then this is the third quartile, and this is for the first quartile. Okay, that's all from me. Thank you.
There are two different types of variance. There are ungrouped and grouped. Definition of variance is the expectation of the square deviation of random variable for its mean. It measures how far a set of random numbers are spread out from their value. This is the formula of the variance. This is mean. For example, find the variance and standard deviation without data of 6, 3, 5, 3, and 8. The solution is 6 plus 3 plus 5 plus 3 plus 8 over 5 equals to 25 over 5 and equals to 5. To find variance, just use variance 5 equals to 2.23. Next is variance for group data. For example, this table shows group data. The mean of this data is 34.25. This is the fx and this is the frequency of the data. And this is the mean. 682,356 over 50 minus 23.25. So this is the answer of this, and equals 13623.87. Variance, the answer of the variance is 116.72.
Okay, I will present about standard deviation. Standard deviation is a statistic that measures the distribution of the data set relative to the mean and is calculated as the square root of the variance. Square rooting the variance that we got before. The low standard deviation indicate that the value tend to be close to the mean, and the more data disseminated, the highest the standard deviation. The formula we use for standard deviation depends on whether the data is being treated as a population itself or whether the data is a sample representing a larger population. Okay, if the data is being treated as a population by itself, we divide by the number of data point is n. If the data is a sample of a larger population, we divide by 1 less than the number of data point in the sample. Okay, for the sample standard deviation for ungrouped data, the sample standard deviation is the square root of the sample variance. Look at this. Okay, this is the sample. The sample standard deviation is calculated using the following formula data. The example of question: find the variance and the standard deviation of the sample data below. 1, 7, 2, 5. Okay, the solution is total of x equal 1 plus 7 plus 2 plus 5 equal 15. Square plus 2 square plus 5 square equal the total of x square is 79. Okay, for the variance, okay, this is how to find the variance. Okay, s square equal 1 over n minus 1 in a bracket summation of x square minus summation in a bracket summation of x over n, and okay, n is the total of data while x is the total of frequency. Okay, 1/4 minus 1 in the bracket 79 minus 50 square over 4. Okay, the total of this is 7.583. Okay, for the standard deviation ni jawapan sorry okay, jawapan ni masukkan je dalam ni and then square root dia, lepas tu dapatlah jawapan ni 2.754. okay, that's all.
The next one is squeeness. A measure of squeeness is used to determine the difference between the mean and mode of distribution. If mean minus mode equal to positive, the distribution is skewed to the right or positively skewed. If mean minus mode equal to negative, the distribution is skewed to the left or negatively skewed. And if mean minus mode equal to 0, the distribution is symmetrical. The Pearson's coefficient of squeeness is usually used to measure the squeeness of a distribution. It is calculated as follows. It have two different type of formula. The first one is mean minus mode divide to standard deviation, or 3 in a bracket mean minus median divide standard deviation. Example, if the mean given 6, the mode is 7, and the standard deviation is 0.5, find Pearson coefficient of squeeness and explain the distribution. So, mean minus mode. The mean is 6 minus 7. 7 is the mode. Divided by 0.5, the standard deviation. You will get negative 2, which means the distribution of the data is almost extremely skewed to the left. For the next example, we will get our eyes in the screen. For the first table, we only get 2 columns, which is for the total asset and for the frequency. So we need to find the mean, standard deviation, and coefficient of variation. Calculate the median and determine the type of distribution in terms of squeeness. So for the solution, before that, it only have 2 tables, but now it have 1, 2, 3, 4, 5, 6 tables, which means we upgrade it to have a midpoint, fx, fx squared, and cf. So we will calculate the mean first, which is the total of fx divided into total of f, and the total of fx you will get it from the table, because before we did this, we will calculate all the things and put it on the table. So the total of fx is 48,550 divided by 127. So we will get 382.28. So after that, after we get the mean, we will count the standard deviation. The standard deviation formula are look like this. All this information in this table, in this formula, you will get it from the table above. So you must do the table before you answer this question. So when you put all the information in this formula, you will get like this. And for the bracket, we need to solve the bracket first, then we do the outside of the bracket. And after we calculate this, we will go through this and this, after this, and After we get this answer, we will do like this, and the final answer is 135.03. So that's for the standard deviation. For the next step, we need to do the coefficient of variation, CV. So the standard deviation answer and the mean answer before this that we already calculate times by 100, and you will get like this, and the answer is 35.32. So the mean is 382.28. The standard deviation is 135.03. We get this from the things that we calculate at the above, and the coefficient of variation is 35.32. This is the coefficient of the variation. After we find the standard deviation and the mean, we will use that thing to find the coefficient of variation. After that, we find the median. The median formula is lower boundary plus n over 2 minus f cumulative frequency and frequency times by 100, and you will get like this, and you will get 406 as the median. So for the Pearson coefficient of squeeness, we use the second formula, which is squeeness equal 3 in bracket mean minus median. So all the things that we get from the above, you will put it in this formula, and you will get negative 0.5269. So that's mean when it's negative, it's slightly skewed to the left or negatively skewed. So the first example that I show is negatively skewed. For the next example, we will use this example to find the first formula of squeeness. So same like above, we will get two tables, and after that calculate the mean income of the workers, compute the standard deviation for income of the workers, find the mode income. So we will get another 6 table, and we will do the mean first and the standard deviation next. After that, we do the mode class. And when you get the mode class, you will do the Pearson measure of squeeness, which is we use the formula, the first one, which is mean minus mode equal and divided by standard deviation. So we got this, and after all this we calculate, and we will get 0.8276. That means the data on workers' income is to the right or positively skewed.
So my name is Rosmina Mansasang, and today I want to present about business statistic, that is correlation and regression. That is, so correlation divided by 3, that is linear correlation, Pearson correlation, and Pearman strength correlation. So the first one is linear correlation. Linear correlation used to test relationship between two variables, which is quantitative and categorized variables. So it is provided with measure to evaluate the strength of the relationship, and there is two methods are commonly used for this purpose. So the next is Pearson's correlation. It is normally denoted by R. So if R is 0, that means there is no relationship between the variables. So if R is positive, it means S1 variables gets large, the other also get large. So if r is negative, it means that's one, as one gets large, the other gets smaller. So the formula of Pearson correlation is here. So where is R correlation coefficient and number of observation and so on. And the next is Pearman's ranks correlation. So it is no parametric measure of the strength and direction of society and exist between two variables that are at less ordinal scale. So it is done by the symbol P. So first we make a list of the n subjects. So you know the value of P is between negative 1.0 to 1.0, that is here. So it is strong positive linear when P close to 1.0. So there is strong negative linear when P close to negative 1.0. So the formula of Pearman's ranks is here. So where is n is number of observation of subjects. Okay, so the question is, an agriculture research organism tested and particular chemical fertilizer to try to find out whether an increase in the amount of fertilizer used will lead to a corresponding increase to the food supply. So the amount of fertilizer is 2132453. So the postulates of beans is 4343655. So the solution of location before is, first make a column and write down the data into a column, then calculate the data to find the x square, y square and xy. So to find the x square, so this is the data of in the question before. So to find the x square, you should do like this. So first, this data, so to square 2. So the answer is 4. This. And then, and so on. So second, to get y square, so you should look for y. So make it same at x square. So 4 to the power of 2 equals 16. So 4 to the power of 2 equals 16, and so on to get the answer. And then next, to get the xy, so you should look at this x and y. So for example, 2 times 4 equal 8. So here are the things. 2 times 4 equal 8. Okay, so secondly, enter the number of the graph by the formula and find the solution. So we calculate like this. So after the number entry, and then we should calculate the number in the bracket first. So here, this and also this number, and then after that we will get the answer like this. And then we calculate again this number, so we got this, and calculate again until we get the answer is this. So the answer is R equal 0.811. So means the correlation is very strong positive correlation because it is 0.6 above. So next is, so the thirdly, calculate the Spearman's line correlation with the following the formula. So the formula is this the formula. So the data is this. So calculate this square different the data between the fertilizer and richness of beans, means the number of the data minus and the all amount of the data plus it to get the number of d square. So here, so So to find the answer of this square, you should do like the data before. So 2 minus 4, and for example, in bracket 2 minus 4 plus open bracket 1 minus 3 plus and so on, do like the same thing to get the answer like this. And then after we get the answer is 18, and then based on the formula, fill in the blank the number in the formula following the formula. So we get this, and so calculate the number, but calculate in the bracket first to get the answer, so easy to calculate. And then we got this, and then this, and then the answer of the question is this. So the answer is P equals 0.679. Okay, so the next topic is regression, also divided by 3, that is regression line, the least square regression line of y on x, and coefficient of determination, that is r square. So first is regression line, which is the scatter diagram should have two axes are drawn with one x-axis and one y-axis. So the scatter diagram able axis if there is a relationship between the two variables. So the method of regression lines is with positive slope indicated that there is a direct relationship between the two variables. Okay, so the linear regression equation for sample data can be informed by y equal a plus bx. So next, is the least square regression line of y on x. So means is the line that makes the vertical distance from the data points to the regression line as small as possible. So the line sum of square deviation between the estimated, so extreme values of the dependent variable for the sample data is minimized. So the third is coefficient of determination r square. So the ratio of the ratio of the explanation variation, and more commonly known as r square, or in bracket r to the power of 2. So the linear relationship is between two variables when the strong. So for example is r to the power of 2 equal explained variation divided by total variation. So for example, the question is, State Bank of India recently established a new policy of linking savings account interest rate to the repo rate, and the audit of the State Bank of India wants to conduct an independent analysis on the decision taken by the bank regarding interest rate change, whether those are being changes whenever there have been change in the repo rate. So the data of the question is this. So month repo data banks rate. So the January repo rate is 3 and banks rate is 2, and so on. So okay, the solution is, first construct a column and find the x square, x, y, and y square. Also fill in the number into the formula to find the y equal a plus bx. So how we to find the x square is, so as we know, the repo rate is x, and the bank's rate is y. So here it is. So repo rate is x, and the bank's rate is y. So to find x square, you should do like this. 3 So to find the x square is, so the x is repo rate, so the data is 3, 6, 9, 11, 16, 18, and to find the x square, 3 square equal 9. So that is how we to find the answer is. So and so on. And then also to find the y square, do something like x, which is the data 2 square 2, and we will get the answer is 4. And do like the same thing to get the answer. And to find the xy, the x and y should be times or multiply. So for example, 3 equal to, we will get the answer is 6. And do the same thing to others. 6 times 8, we get the answer is 48. This 9 times 11, we will get 99, and so on. Okay, so secondly, calculate all the following the formula to get the y equal a plus bx, but calculate b first. So the b is here. The formula b is here, and then the data that we calculate already fill into the formula, and we will got this. And then, as we know, the big of number is into the column. Okay, so number which is into the bracket should calculate first, so it's easy to us to calculate it. So, and then after that we will get this, and after we calculate all this, and we will get this, and 989 minus 787.5 divided by 827 minus 661.5, and then the answer we will get the answer this. And then after we divided the number, we will get this. So the answer of B is 1.28. So the answer of B is 8.218. Okay, so the next is, so the formula of A is this. So after we fill the number into the formula, and we will get this, and after that we calculate until we get the answer, and this is the answer of A. So to find the answer of y equal a plus bx, so the question is when x equal 5, that means when x is 5, so we fill in the blank. So this is the answer of A, which is this, and this is the answer of B. The answer of B, this. So after we fill it, and we multiplied by 5, so the answer of y is y equal 5.801. So next is when x equal 14. So which is means x is 14, and then we fill in the blank, same as fill in the blank, and so we fill it, do like this, and after we calculate it, we will get the answer is this. So y equals 16.763. So that is the answer.
Okay sir, that's all from us. Thank you for watching our video presentation, and sorry if I did kurang ke apa. Stay safe, stay at home. Bye. Assalamualaikum.